Okay, today on this vlog, we're going to talk about special factoring techniques. Now, the first technique we're going to discuss is the difference of squares. Now, what does that mean? Difference between two things. We're going to subtraction of two perfect squares. For example, here in front of us. If you remember, if you've already worked through multiplying binomials and polynomials, it's a topic I've covered in the past or in other vlogs. When you multiply x minus y times x plus y, and if you distribute this over, you'll see what happens as we do it here. Okay, now you can see we have these middle terms minus xy and plus xy. When you add them together, they become 0xy. They drop out effectively. They drop out. Now that minus sign is when we talk about the difference of two squares. The difference between x squared and y squared. X squared minus y squared. Now we've worked on the multiplication part. Now we're going to divide it back out again and work back to where we came from. Now, if I see this and recognize it, I can jump and say I know the quantity. It's x plus y, parentheses, times, parentheses, x minus y. So, it looks pretty easy, to do, but the question is, how am I going to know? How do I know the difference of two squares if I can recognize this? Part of the technique is to know your perfect squares, the numerical points. Like, if something is a perfect square, its square root is a whole number. Okay, see my examples here. So we have to recognize these two numbers as perfect squares. They have square roots that are whole numbers or whole variables. And even before you look at that, if it's a squared thing plus a squared thing, you just stop. You can't do it. You can't use this method. But if it's a perfect square minus a perfect square, you can factor it. No, we're going to factor it soon. I'm going to list some perfect squares, meaning they have square roots, and the square roots are whole numbers. Really, there are many, many perfect squares. These are several examples. If you're using a variable, it has to have an even power. It has a square root then. If you had an odd power like x cubed, x to the third power wouldn't work out, does not have a square root that has a whole number for an exponent. And our traditional perfect squares, 16, 25, 36, 49, 64, 81, and then 100, and so on and so on and so forth. Now let's go through some examples and see how this works. Okay, now both conditions are satisfied. M squared does have a perfect square, so it's an m, and 16 squared root of that is 4. Now what do I do? And it's also a subtraction problem, so I'm good. So I had m and 4, m and 4. Now, they're both not negative, and they're both not positive. It's a mix. One's positive, one's negative. So it's m plus 4, parentheses, open, close, and then parentheses m minus 4. Okay? We're going to go through and check the first one here, but not the next two, but you can check them on your own. So make sure we're correct. Okay, I was correct. Now the second example, we have x squared minus 49. Well, x squared, of course, is a perfect square. It would be x is the square root of it. And then 49 has a square root, and that's 7. So that means I can use my my method here. We're going to move to the third example here. X squared plus 16. Well, gotta stop right there. It fails. We can't use this technique because it's not the difference of two squares. It is the sum of two squares. So therefore, example C is prime. We are not able to factor it. Thank you for watching. See you next vlog.